What if I told you that engraved into the lunar surface is a historical record that could provide critical insight into the history of our own planet? Carved deep into the lunar surface are many stories. Stories, if they had occurred on Earth, would have been washed away by geological forces. But the moon is a Rosetta Stone and timelessly holds the evidence of something beautiful, awesome, and even sinister. Today, we'll be exploring recent discoveries on the moon, their secrets and revelations, now imparted to mankind, and perhaps some crucial lessons learned. Here today on Squaring the Circle. Greetings. I'm Randall Carlson, and this is my podcast, Squaring the Circle. Today I will be joined by my friend, colleague, and ally, John Arthur, and welcome to the stage, John.
Glad to be here, sir.
Glad to have you. So, John, I just recently spent virtually a whole week with you, and you with me, and a whole group of about 40 other people, I think?
Yes, sir. I think it was 38.
38. Did that include the staff?
I'm not sure. It was right around there.
Okay. So what were we doing?
Well, we were touring the Lake Bonneville floodplain.
Uh-huh. We started in Salt Lake City. We had some tour buses and a group of really fun, interesting people that many of who were old friends from previous events and tours that we've done. And we started in Salt Lake City, and we drove north through Red Rock Pass out onto the Snake River Plain. We diverted to the northeast, and we visited the ruins of the Teton Dam disaster, which was very interesting and informative in multiple ways, I found. Did you find that?
Well, for me, it was the highlight of the trip. We had a wonderful lady from the local museum come out, and she gave us a great dissertation on the building of the Teton Dam, but that was interesting, and then also just the fallout from it, and very enlightening in the thought process of understanding the Bonneville flood. Yes,
it was. Even though it was an epic flood, a huge flood in its own right, it was still minuscule compared to the ancient flood whose evidence we were following in the landscape. And I will mention that we got enough documentation and data that we will be doing a presentation and telling that story. It's a really valuable, important story. What happened? Because that was the last monumental dam project in America undertaken by the Bureau of Reclamation. And there's a story that needs to be told there with multiple lessons that we can extract from it. So that will be coming up in the near future. We will get together and we will tell that story about the Teton Dam disaster. And then from there, we followed the route of the Snake River, which was the pathway of the Great Bonneville Flood. And we saw some amazing landscapes. I think you would agree.
Absolutely. It was gorgeous. Couldn't point the camera in an ugly position.
Right. Or in a position that didn't have a hell of a story to tell. Yeah. Think about Massacre Rocks. My gosh. You know, when you're standing there, or Swan Falls Boulder Bar, or the canyon there at Shoshone Falls. I mean, there was no Bruno Canyon. I mean, the list goes on. These were epic events that left a lasting imprint into the landscape of the Western United States. And I think everybody who was on that tour came away with their eyes opened to some of the incredible events, mind-blowing events that have transpired in our own backyard. You know, at this point, I've spent many weeks, months, traversing these landscapes that could only be created under conditions vastly different than what prevails there now in the present. It raises questions, and those questions haven't been answered. So we're faced with the idea that there have been these tremendous outsized events that have occurred on this planet. And that, coupled with the idea that we now know that life has been profoundly affected by catastrophic events, mass extinction events have been not some, well, even the term mass extinction is relatively new in the lexicon. Once upon a time, it was just extinctions, because extinctions were considered to be long, slow, drawn out, incremental things. And as fast as species were going extinct, they're being replaced, right? Well, that model of life history on Earth is completely obsolete. We now know there are these epic mass extinction events that might eliminate half, 3/4, or even 90% of all species on Earth, both terrestrial and marine. Well, the thing now I think that we're moving towards is that same model applied to human civilization, that we have to look at mass extinction events relative to human civilizations that have risen and then abruptly fallen for no obvious reason, other than the fact that perhaps you had cultural groups that were not adaptable, not prepared for natural changes in the environment and the climate, that basically pulled the rug out from their efforts, from under their efforts. So I think this is one of the most important insights as an evolving civilization on Earth that we can have, is the realization that there have been these gigantic outsized events, sometimes over vast areas of the Earth's surface, large regional events, continental events, and even global events, right? Which leads us to, I think, some of the implications of what I call the new catastrophism. And one of the things I'd like to quote here is from an interesting paper that came out, oh gosh, when was it? I think it was 2020. I'll get the origin of this in a second here, but let me quote from this paper. It was by William E. Burroughs, published December 14th, 2020. Title of the paper is this: "The Big One's Coming. If we don't want to go the way of the dinosaur, it's time to colonize the moon." Which I think brings us back to the discussion we had in the previous episode of Squaring the Circle. We're talking about, finally, now humankind is getting motivated and inspired to return to the moon. Okay. Now, this interesting story, and I will provide the source for this so people can go in and read the whole thing for themselves, because it's quite interesting. But it starts by quoting from a novel called Encounter with Tiber. So that apparently would maybe is a reference to Rome, maybe, which was founded by Romulus and Remus on the River Tiber. So there was an epic novel written by Buzz Aldrin, who was an astronaut, and John Barnes. And in this novel, the story revolves around a multi-generational intergalactic spaceship. And so there's a conversation going on between the commander, called Ozapak, I believe. I'm not sure how to pronounce it, but she was the commander of this multi-generational intergalactic spaceship. And here's the quote: "There's not a place in the universe that's safe forever. The universe is telling us, spread out or wait around and die." End of quote. And then goes on to say, "Astronomers and scientists around the world who have studied the solar system and beyond have seen damage to every solid body they scrutinized, and know that the universe is as abidingly dangerous as it is beautiful. As Galileo observed in the year 1610, when he trained his primitive telescope on the moon and saw impact craters. And I'll mention millions. We now know there's millions of impact craters on the moon. Solar system exploration has borne out what astronomers have seen. Voyager 2, the first interplanetary spacecraft to scrutinize the 4 major planets beyond Mars on its aptly named 12-year grand tour, sent imagery home that not only provided scientists with a virtual library of information on the planets, but that, like its Pioneer 10 and 11 predecessors, showed the Jovian moons to be heavily cratered by impacts made by very large rocks moving at terrific speed. He then goes on to talk about one of my heroes, the late Gene Shoemaker, who was instrumental with his wife Carolyn and David Levy in the discovery of Comet Shoemaker-Levy 9, which we witnessed impacting Jupiter back in July of 1994. I think one of the most important astronomical events of the 20th century, because it really did alert the human species that, yes, giant impacts occur on planets. We're witnessing one, right? But not just one. We witnessed 21 of them. And I think that opened the door to something I had already suspected by then, which was that multiple impacts were far more common than we had imagined. So the Big One's Coming paper goes on to talk about Gene Shoemaker, who was actually killed in the outback of Australia, going to research a crater that now bears his name, Shoemaker. And while I'm reading this, you might pull up an image, if you will, of Shoemaker crater. So Gene Shoemaker was a planetary geologist, and he said that the next time a really big asteroid or comet crashes into Earth, it could cause an explosion equivalent to all the world's nuclear weapons going off at the same time. It could cause mass extermination. Now, while that's absolutely true, it's also true that a much smaller impact, or maybe even a multiple impact event that did not carry nearly the energy, let's say, as the dinosaur killer, maybe wouldn't cause a mass extinction that would show up in the geological or paleontological record millions of years from now. But it could certainly cause a civilizational or cultural mass extinction. Ask any dinosaur what that's like. Now, here's the point I want to stress. What is the probabilities of a dinosaur scale impact occurring? They're in any time in the next few centuries. Well, they're very low. But a much higher probability would be a much smaller event that maybe, like I said, would not cause a mass extinction on the scale of the Great Five, which is something we actually need to dive into at some point, talking about those, but could certainly cause the collapse of civilization, and not the extermination of the human species, but the retrogression of the human species back to a Stone Age existence. Because our technological civilization is actually far more vulnerable than people realize. And even a small cosmic event could cause serious disruption. Here we go. The Shoemaker impact structure lies in the arid central part of Western Australia near Walloona. The crater is about 30 kilometers or 18 miles in diameter and contains seasonal lakes. Yeah, we see some of those seasonal lakes there. So he was on his way to explore. He was exploring this and documenting this crater when he was killed, apparently in a very freak accident. I mean, you're out in the back in the Australian backcountry where you presumably are not encountering heavy traffic, and there was some kind of a crash. I think in his. You might look up Gene Shoemaker. It might tell us about his demise. I want people to know about Gene because he was heroic. He was the one that trained. He was primarily the one who was in charge of training the Apollo astronauts and teaching them. And some of the sites that I've been to were sites that NASA used to train astronauts to understand impact phenomena on the moon.
So he passed away in a head-on car collision on the remote Tanami track, a few hundred kilometers northwest of Alice Springs, Australia. His wife, Carolyn, was severely injured in the crash. In 1999, some of his ashes were carried to the moon by the Lunar Prospector space probe in a capsule designed by Carolyn Porco.
Oh, wow. Okay. See, I'd forgotten that. I remember now, but I had completely forgotten that yes, some of his ashes were carried to the moon. And then what? What happened to him?
So that they were put on the Beringer meteor crater, and a quotation from Shakespeare's Romeo and Juliet was inscribed there. And when he shall die, take him and cut him out in little stars, and he will make the face of heaven so fine that all the world will be in love with night and pay no worship to the garish sun.
Wow. So that was Gene. And, when I worked on the Fire from the Sky back in '96, one of my regrets was that we did interview Gene Shoemaker, but I was not able to be present at that interview. But he was interviewed at my recommendation, so that was a disappointment of mine. And I always thought I would get the chance to meet him until, of course, I mean, who would think you're going to get in a head-on collision out in the middle of the Australian outback, like it said, remote?
Yeah.
So anyways, in the paper by William Burroughs, he goes on to say, after referencing the dinosaur extinction, ask any dinosaur what that's like, he then says, "It is therefore imperative that we adopt a dual strategy for survival. Start an active planetary defense system that can spot potential impactors close in and divert or destroy them, and establish colonies on other worlds, starting with the moon, to spread out rather than die." I will also mention that there's another option there. He says that we can spot potential impactors close in and divert or destroy. On the other hand, those impactors, bear in mind, the more dangerous they are, the closer they are coming to the Earth. But the closer they are to the Earth, the more accessible they're going to be. And so I want to see, within a generation, I want to see asteroid mining getting underway, whether with humans in space or robotic. Maybe it could happen all robotically. I think that a lot of it could, but I think that a human presence is still going to be necessary. But I believe that that's something that needs to happen sooner rather than later. And of course, what we now know about the asteroids as a resource is that pretty much everything that we're mining the Earth, that we're extracting from the Earth to build our industrial civilization, is available in the asteroids or the lunar regolith. So with that in mind, there's been several interesting new developments in our studies of the moon. Let's get into that a little bit. Do we want to talk about these tremendous, since we've been talking about the potential of impacts, let's look at the impact of one of the great impacts on the moon, which created the Schumacher. You want to pull that one up again you had?
Yes, sir.
There's Shoemaker and Schumacher.
Schumacher. So here's Schumacher.
Is that it? Schumacher.
Schumacher crater.
Oh, Schumacher crater. Okay. I'm sorry. I was momentarily confused. I was thinking of Schrödinger crater.
Schrödinger crater. Let me pull that one up real quick.
Yeah, because that's the one that
that created the two valleys.
The two valleys we want to talk about. If people haven't seen this already, if you haven't already, subscribe to my newsletter. I covered this in the May newsletter from this year, but let's get into it a little bit here. There it is. This is Schrödinger on the moon in the southern part of the far side. And this is close to where some of the Artemis landings are supposed to take place. Several things interesting here. Notice you've got this central ring here. I don't see an uplift, but there is so this was originally a multi-ringed crater. Let's see, what can we find out about that crater? Let's see if, look at this. There's an oblique view. Oops, go back to where you were. Okay, so we can see, I believe, one of the great canyons we can see going off here to the, right in there, yeah. And we're gonna be looking at that. Schrodinger, pull up the data on Schrodinger, or I could do it if.
Let me see here. I'll pull it up. So
there's another one. Valles Planck extends from the crater to the upper right of center. Oh, look, yeah, you can see it up here.
Nice
see this
and clear.
Long? Yeah, nice and clear. Oh yeah, look at that.
So 2 Grand Canyon-sized valleys on the far side of the moon formed within 10 minutes. This is a headline from ABC Action News.
Okay, and you can see this is Valles Planck going up here to the left, I believe. And then Valles Schrodinger is the one going up to the right. It's not quite as prominent, but there it is. Yeah.
Yep. The impact here, and then you have the 2 valleys get carved out.
Yeah.
About 3.8 billion years ago, 2 massive canyons likely formed on the moon in a span of less than 10 minutes.
Less than 10 minutes, yeah.
Less than 10 minutes. The extraordinary formations, each comparable in size to Earth's Grand Canyon, are hidden on the far side of the moon, the side that always faces away from Earth, because it's in a stable orbit, with the far side always being far
away from us. Yes,
away from us. So the lunar canyons are both part of the larger Schrodinger impact basin, where an object yet to be identified slammed into the moon billions of years ago. The colossal impact also led to the creation of the canyons as well, according to a new study published Tuesday. In the Journal of Nature Communications.
We're taking a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I had remembered to do that. So that night I put some of the salve on, went to bed. Though I've being in the construction and building industry, I've had many falls and injuries and stuff. And I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week, I was getting around pretty good. I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. Okay, so there it is. That's a nice, clear image. Let's go to the next image here. You can see. Okay, so here you can see right down here is the South Pole. You see how close it is to the South Pole. And the impact occurred, would have been an oblique impact coming in from like this direction, if you can see my cursor. And you can see that the impact caused this massive fan to splay out. This would have been a combination of debris and magma formed in the tremendous heat generated by the impact. And right here, look at my cursor. You can see here's one of the canyons, and here's the other canyon. And you can actually follow those canyons like in a V, and that point is where the first encounter would have occurred. And the object was probably moving at 30 miles per second, something like that. And so when it hit, it made a massive explosion, plowed into the crust of the moon, I think it was estimated to be at least 15 miles deep originally. And so here's an oblique view, and you can see the two canyons. Here's Planck coming out this way, long and linear, and here's Schrodinger coming off this way. You can see the arrows are pointing to the two canyons. They are larger and deeper than Grand Canyon. They're comparing to Grand Canyon, but they're actually greater in scale than Grand Canyon. Let's go to the next one here. So here's the Grand Canyon, 1.8 kilometers deep, right? Distance along the transect. So this is a transect or a cross-section of the deepest part of Grand Canyon, okay? And 1.8 kilometers, that's about a mile, right? Go to the next one, and you'll see that here is Valles Planck, 2.6 kilometers. Now, let me do a quick calculation. 2.6 times 180 equals 1,5,280. So that's 1.6 miles deep. So that's half again more than the depth of Grand Canyon. And let's look at here. Apparent crater floor, right, is this. Prior to slumping, it was this, right? So after the impact, what they're calling here the post-impact fault, you had a lot of material that slumped down into the crater, filling the bottom of it, all right? And then what it's calling the crater breccia lens. The breccia is the fallback stuff. So you have the impact, a bunch of this stuff is blown up into the sky. I won't say atmosphere because moon doesn't have an atmosphere. And then it falls back. So you had the fallback breccia that cut off the bottom. So it was actually the original crater, or the original valley was actually deeper. Then you had this slumping into it that made it even shallower, but it's still 2.6 kilometers. And let's see, I think the next one shows how it was formed. So what you had was, imagine you've got this linear chain of material being thrown out from the impact. Here comes the impact in like this at an oblique angle. Boom! It explodes, but splayed out from that point of impact are two almost trains of debris, almost like we could imagine Shoemaker-Levy 9. And then boom, 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 they're hitting right after one another in a chain or in a sequence, and that's what excavated and threw out this. So it was this secondary impacts that excavated the canyons. So this is Schrodinger here, and you can see, you can actually count 1, 2, 3, 4, 5, 6, 7, 8 impacts just in this section right here, hitting each other. Just, they would have been closely spaced, just like boom, 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 right after one another, gouging out this tremendously deep canyon.
Now, on Earth, all of that would have succumbed to erosion after this after this long. But
Correct.
here on the moon, it's perfectly preserved.
Perfectly preserved, yes.
And so it gives us kind of an insight as to what one of these impact events looks like. Maybe not immediately after, but we can reconstruct what it would have looked like at the time. Correct.
Yeah, and that's why I think in the opening statement I referred to the moon as the Rosetta Stone. Because see, here's the thing: if we were to remove the geological processes on Earth, plate tectonics, continental drift, subduction, the biosphere, the hydrosphere, the cryosphere, all of these things that are constantly modifying the surface of the Earth, guess what it would look like? The moon. It would look like the moon. And if anyone doubts that impacts are an ongoing process in the solar system, I mean, just go out with a pair of binoculars at night and look at the moon. Just look at the moon. And then remember that, oh, yeah, there was the Great Bombardment episode, sure, billions of years ago, but it's been ongoing since. And was shown to us, demonstrated directly by Shoemaker-Levy 9 in 1994. I think it was Shoemaker himself, or one of the planetary geologists, that said this is a once-in-a-lifetime event. And my response is, well, okay, but what do we mean by that? Yeah, nobody expected to see anything like that. It was completely unexpected. And there was a lot of astronomers that began to reconsider the impact probabilities in the aftermath post Shoemaker-Levy-9 reality. And, again, we've got one example, and I don't know what your statistical framework would be. But what that tells me is the very real possibility that events like that are way more numerous than we had imagined. If we were to see it again, something like that again, I mean, is it going to be 1 million years before something like that happens again? 1,000 years, a century, a decade? We don't know. We don't know. The next graphic is really cool because it kind of shows the scale. Let's see, which one was this? This was Schrodinger. You can see the astronauts here standing on the rim looking into this valley that's bigger and deeper than Grand Canyon. And I sure would like to live to see the day when humans are standing on the rim of this canyon. I want to see drone footage, a drone flying up this canyon.
We're close.
Or close. I want that. And I think I would like to see millions, even billions of my fellow humans want that same thing. Because, again, the question is, what's the alternative? What is it? If you don't want to do this, if you don't think we should expand into the cosmic frontier, what's your alternative?
I'll relapse into hedonism, but that's a different topic for a different time.
Relapse into hedonism, yeah. I mean, it could. Until, of course, the infrastructure of our civilization collapses. Yeah.
But that's a different issue.
That's a different issue. But it would be worth exploring. Let's talk about some of the specifics of going back to the moon. And one of the things, of course, the problem with establishing a lunar base, a colony on the moon, is the problem of radiation. And how do we solve that problem?
Well, there's a new discovery out on a really, really interesting cave under Mare Tranquillitatis.
Yeah. Let's segue into that by looking at first of all, one of the very recent proposals that have been made for solving that problem. This was a paper that was published in the journal Planetary and Space Science this year, just this past April. Sylvain Blunier and 5 others authored this. It's entitled A Regolith-Based Lunar Habitat for Astronaut Protection and Organ Dose Assessment. So this new report was on ways to mitigate the risk from galactic cosmic rays and solar flares during lunar missions. The authors of this report point out that, and I'm going to quote here, future habitats must be designed with robust shielding against these hazards. Turns out there is a potential solution in the form of lunar regolith. Now, here's the definition of lunar regolith. The layer of loose rock, dust, sand, and soil resting on the bedrock that constitutes the surface layer of most dry land on the Earth, the moon, and other large, solid, aggregated celestial objects. End of definition. It is readily available on the moon, and it does not incur heavy transport costs that would occur with the lifting of prefabricated materials from the Earth. So for this work, the authors simulated the effectiveness of a 2-layer dome with an inner layer consisting of a thin aluminum-based alloy covered by an outer layer composed of regolith. So this is what the authors explain in their introductory remarks. Amid growing geopolitical competition, national space agencies are increasingly focused on returning to the moon. Unlike the Apollo program, the Artemis program aims to establish a permanent base where astronauts will stay on the lunar surface for extended periods ranging from weeks to several months and brave the harsh environmental conditions. Among the foremost concerns is the threat of space radiation and its potential impact on astronauts in the short and long term following exposure. End of quote from the paper. So among the radiation hazards that are faced by astronauts are, one, solar energetic particle events, acronym SEP, that usually occur during solar maximum periods. When the sun goes into a hyperactive stage, it starts spewing out these highly energetic particles, right? And this forms a type of radiation that could affect living things, would certainly affect humans on the moon, right? The other one are galactic cosmic rays that occur when the moon is in a quiet period, because when the moon is active, when the sun is active, the solar wind acts as a buffer that essentially shields or insulates the Earth from the most intense of the galactic cosmic rays, which is symbolized by the acronym GCR. So you have a highly energetic solar particle events during periods of hyperactive sun, and during periods of quiescent sun, of inactivity, that now allows the galactic cosmic rays to get in. And so that dominates during periods of solar inactivity. So these two threats to astronaut safety are considered distinct threats, and they have to be treated separately since their biological effects are between GCRs and SEPs are different from each other. And now I'm going to show a diagram. So you can see here, let me just enlarge it a little bit more. Okay, so this is, you can see here, this is just a domed, it looks kind of small to me. I think I'd be a bit claustrophobic in that. But the same principle would occur on a larger scale. And you can see here, you've got like the virtual source, which is the starting surface. And then you've got here's your 4 millimeter thick aluminum dome. And then you've got your layer of regolith. And so right here, this is showing this would be enough to mitigate or filter out the cosmic rays and the solar energetic particles. And then you can see sort of a 3D view over here. See, maybe I could even go in a little further. So that's one possibility of creating these domes. Now, how could you do that on a larger scale? Well, that's being explored right now as we speak. So that's one possibility. But there's another possibility that you were actually referring to a few minutes ago. And what was that? What was that possibility? Do you remember?
Yeah, I do. So we were kind of talking a little bit about the cave that has been discovered on Mare Tranquillitatis. And this cave is really interesting because it's a lot wider underneath than it is at the surface. There's a cistern-like cavern here. And this also from NASA. If you're listening on audio, my apologies, but I'll try to explain as best as possible. Thank you for being on Apple or Spotify, wherever, but we're also on YouTube and Rumble. But we're looking at a 100-meter cross section at the top for this one cave. And now we have evidence of conduit caves that are 170 meters deep. So 100 meters wide, 170 meters deep. potentially conduit caves connecting some of these openings in the lunar regolith and actually the lunar surface rock. We actually have a place where you could build a space station or habitation.
A colony.
Full colony.
Below the surface of the moon.
Which is amazing. And before you say, well, there's no resources, well, there's some other really interesting evidence. By the way, we were talking about the moon being a fantastic time capsule. Real quick, I'll share this. This is from NASA. NASA mission uncovers the moon's buried treasures. Again, we'll put this link in the description, but this is really interesting. NASA has convincingly confirmed the presence of water ice and characterized its patchy distribution in the permanently shadowed regions of the moon, like the cave that we were just speaking about. They dropped one of the boosters from the LCROSS, and when that impacted, kicked up a huge regolith plume. And in that plume, I'll read from here, the twin impacts of the LCROSS and a companion rocket stage in the moon's Cabeus crater on October 9th, 2009, lifted a plume of material that might not have seen direct sunlight for billions of years. As the plume traveled nearly 10 miles above the rim of Cabeus, instruments aboard the LCROSS and the LRO made observations of the crater and debris in the vapor clouds. That's the important part here. After impacts, grains of mostly pure water ice were lofted into the sunlight and the vacuum of space. Seeing mostly pure water ice grains in the plume means water ice was somehow delivered to the moon in the past, or, this is important, chemical processes have been causing ice to accumulate in large quantities. They also see volatile compounds and like methane and a few other things present in this discovery. So really, really interesting stuff that is being kept in craters, just like the one here near the Apollo landing site, Apollo 11 site. And possibly really good in situ resource mining available, but either comets or, and some of this might be comet debris, but there are some other explanations too. And I don't know if we'll get to it this time, but there are some interesting explanations potentially for how ice is forming on the moon chemically.
Well, yeah. I mean, I first became aware of these holes back in 2010. Where was it? It was it in the journal Science? Let's see. It was an article entitled "Down the Lunar Rabbit Hole." This was published on July 20th. Again, I'll find out the exact reference and we can include that. But July 12th, 2010, a whole new world came to life for Alice when she followed the white rabbit down the hole. There was a grinning cat, a hookah-smoking caterpillar, a mad hatter, and much more. It makes you wonder what's waiting down the rabbit hole on the moon. NASA's Lunar Reconnaissance Orbiter, or LRO, is beaming back images of caverns hundreds of feet deep, beckoning scientists to follow. Says Mark Robinson of Arizona State University, principal investigator of the LRO camera, said they could be entrances to a geologic wonderland. We believe the giant holes are skylights that formed when the ceilings of underground lava tubes collapsed. Japan's Kaguya spacecraft first photographed the enormous caverns last year. Now, the powerful Lunar Reconnaissance Orbiter camera, the same camera that photographed Apollo landers and astronauts' tracks in the moon dust, is giving us enticing high-resolution images of the cavern's entrances and their surroundings. So here we go. Look at this is one here. This pit in the moon's Marius Hills is big enough to fit the White House completely inside. And then we have another one. This cavern in Mare Ingenii is almost twice the size of the previous one in the Marius Hills. So nobody knows how deep these things go. They could go into a huge honeycombed labyrinth of underground caves. And as it turns out, those caves would be ideal for shielding astronauts or colonies or whatever it might be.
67 degrees Fahrenheit consistently inside those caves.
Inside those caves.
Where you have 200, I think it's 230 during the day and negative 100 and teen something. I'll pull those exact numbers up. I won't misspeak, but keep going.
Yeah. So, I mean, with that knowledge now, it changes the whole equation of colonies on the moon.
It does.
Now, if we had an energy source, that becomes the next interesting question that we'll explore in future is innovations that are on the horizon of energy sources that could be used to power.
And we'll talk about geothermal on the moon maybe next time, because that's a whole interesting study all on its own. But 260 plus Fahrenheit, 120 degrees C during the day, and I misspoke, negative 280 degrees at nighttime, negative 170 degrees.
So that
Celsius.
gets a bit chilly.
So compare that to 67 degrees Fahrenheit, 17 degrees C all day. That's
Wait a minute,
what we want.
57 or 67?
63 degrees. Here we go. So I read one that said 67, and this one says 63. It's 17 C.
Well, that's perfect. To me, I love a 67 degree temperature.
Yeah. So,
I'm too warm when it's 70 degrees. I like in the 60s.
So 63, it's perfect.
Yeah, I'm from Minnesota, right? Okay, so I like it a little cooler.
Yeah.
But so there you've got, yeah. So now let's consider what we've got. We're discovering that the moon is an incredible source of resources and raw materials. The evidence is really supporting the notion that there's going to be abundant water salvageable on the moon. We know that some parts of the lunar regolith are up to 40% oxygen. Now we have these giant caves. I mean, it almost looks like somebody designed the moon just to be there waiting for us so that to make it a little bit easier for us to become a spacefaring civilization.
Why not use it?
Why not? So the lunar arc, this is one of the themes and ideas now we've been discussing, but this was way back in 2007. I saved this because I was already, by 2007, I'd already been thinking for at least a decade or more that the moon was a likely, perhaps, arc for the preservation of human civilization in the event of a catastrophe, a global catastrophe. This is what was published on August 14, 2007 in National Geographic. The moon should be developed as a sanctuary for civilization in case of a cataclysmic cosmic impact, according to an international team of experts. NASA already has blueprints to create a permanent lunar outpost by the 2020s. Well, you see, just as always when government does something, we're running behind schedule, right? And what it's taken is some international competition. It's taken China, India, Japan to say, well, screw you. If you're going to sit on your duff, we're going to the moon. And then we have the private sector, for all whatever you may think about Elon Musk. Look, he's spearheading what could potentially be one of the most important evolutionary developments of human civilization, along with Jeff Bezos. And let's not get into talking about Katy Perry in space. Who knows? I don't know. It looked like a publicity stunt, but who knows? I don't know. Or Virgin Galactic. There's other incipient private space. The private space industry is set to really take off to the next level, and I'm 100% for it. Anyways, let's go on here. But that plan should be expanded to include a way to preserve humanity's learning, culture, and technology if Earth is hit by a doomsday asteroid or comet. said Jim Burke of International Space University in France. And we should probably reach out to them, because what I'd like to see happen is an international network of space enthusiasts getting together to help move this paradigm forward and convince people that it probably is presenting the optimum option for the future of our civilization on this planet. And if you don't think so, well, articulate some alternatives. I'd like to hear it. I haven't heard them. I've been asking for them for 40 years now and haven't heard them. So Burke, once a project manager on some of the earliest American lunar landings, now heads an ISU study on surviving a collision with a near-Earth object. An impact of the size that wiped out the dinosaurs hasn't happened since long before the rise of humans, he pointed out. Yet scientists' expanding knowledge of asteroids and craters left throughout the solar system has created a consensus that Earth remains vulnerable to a civilization-crushing collision. And I've been documenting many near misses since this was published in 2007. I started documenting near misses in 1988, and there have been dozens. There have been dozens. Not ones that would cause mass extinction on the scale of the dinosaurs, but a considerable number that could cause major disruptions to civilization. This called for the creation of a space-age Noah's Ark, Burke said, a lunar ark. Humans are just beginning to send trinkets of technology and culture into space. NASA's recently launched Phoenix Mars lander, for example, carries a mini disc inscribed with stories, art, and music about Mars. The Phoenix lander is a precursor mission in a decades-long project to transplant the essentials of humanity onto the moon and eventually Mars. The International Space University team is now on a more ambitious mission to start building a lunar biological and historical archive, initially through robotic landings on the moon. Laying the foundation for rebuilding the terrestrial internet, plus an Earth-Moon extension of it, should be a priority. The founders of the group Alliance to Rescue Civilization agreed that extending the internet from the Earth to the moon could help avert a technological dark age following nuclear war, acts of terrorism, plague, or asteroid collisions. And then we have a quote here, read, killer asteroids, a real but remote risk. But the group also advocates creating a moon-based repository of Earth's life, complete with human-staffed facilities to preserve backups of scientific and cultural achievements and of the species important to our civilization, said ARC's Robert Shapiro, a biochemist at New York University. Now, in 2007, there weren't any serious concerns about nuclear war. But in the last couple of years, we've moved dangerously closer to that as a possibility. And even now, as we speak, these corrupt leaders in Europe are proposing that Ukraine start launching 300-mile, 400-mile missiles at Moscow. To achieve what? To accomplish what? So, see, that to me symbolizes the alternative. You know, there's a major fork in the road. We're at this fork right now. And people need to fucking wake up, right? Because one or the other, we're going to go down this road and make no mistake. Why are we there? Again, it's about resources. It's about who's going to control those resources underground in Ukraine. Trillions of dollars of resources, precious metals, strategic metals, hydrocarbons, natural gas, all of that, right? So we're willing to risk World War III and potentially nuclear war to struggle over Earth's presumably finite resources. Are we going to go that route, or are we going to go the route of what you and I have just been talking about? Now, if you don't believe, again, I'm going to say this again, if you don't believe that this is something we should pursue, that we should be sitting down with the Russians, the Chinese, whoever, the Japanese, the Indian government, which has now moving forward with a space program, whoever it might be, right? Even the Arab world now is becoming more and more attuned to the idea of establishing their own version of the space program. Well, we need to be sitting down as an international community and saying, what kind of a future are we going to have? If you don't want to do this, if you don't think we need an outpost on the moon, a colony on the moon, a base on the moon, what's your alternative? I want to hear it. I want to hear it in detail. Articulate that. And if you can't do it, then shut up and get on board. Right?
Yeah. Yeah. I mean, really what it comes down to is, do you have a mindset of growing the pie or fighting over the pieces? Do you want to bake more?
Exactly.
Or do you want to just squabble?
Well said. That's exactly what it is.
And there's a lot to explore, a lot to do, and we should be about doing that.
Yeah. And so, Donald Trump, are you listening? You came in with some things that I could have gotten behind. Let's get on with the program. Donald, we need to invigorate our space program. You're saying we need $1 trillion for the military. Well, to do what? I want to hear what our long-term strategic goals are with $1 trillion military. Does that include space, or is the plan to just militarize space? I don't think we need to go down that route. And this is why I would like to ally with Space Force, because I definitely know there's interest in Space Force. I've gotten this directly from former Lieutenant Colonel Matt Lohmeyer, who is a friend of mine. We were actually going to have a conference, and I was going to speak at it at Space Force about planetary defense. This was pre-COVID, and with the onset of COVID, well, that got put on hold. And then we were regrouping after COVID when they started opening things up again. Matt Lohmeyer was spearheading a second iteration of the conference where we would be discussing planetary defense. And then what happened? Well, he wrote this book right here, Irresistible Revolution, talking about how the Pentagon was succumbing to all of this wokeness, diversity, equity, inclusion. It was becoming more important than merit, becoming more important than skills and abilities. In an institution where your abilities and skills should be paramount above everything else, right? And so because he wrote this book and went on a couple of podcasts to talk about it, he got booted from Space Force. He may end up becoming Undersecretary of the Air Force. I hope he gets approved. I haven't heard the latest. I need to look at that, where that's at, if it's in limbo or what. But yeah, so I think there is an interest in Space Force and I think that ultimately that is going to become the ultimate rationale for the existence of Space Force. I think that will at some point supersede the other ideas, which are, securing space for American interests and so on, which I'm for. I don't want it to be taken over by another country, but I believe we need to pursue cooperative. I mean, I was just looking into the building of Grand Coulee Dam and Hoover Dam, which used to be called Boulder Dam, and I have to confess I liked the name. When I was a kid, it was Boulder Dam, and then later changed to Hoover. I liked Boulder Dam better. But when they built, when the bids were let out, when the contracts were let out for bidding on Grand Coulee Dam, which at the time was the largest engineering project in the world at that time. Certainly it was in America. It was certainly in North America, but I think the world, right? There was no single company that could undertake the construction. It was a big, complicated project that had many facets and many skill sets that needed to be integrated. So what happened was 3 companies that had been competitors formed a joint venture. They formed a consortium. And only that way were they able to pull it off. Like, I think it took 5 years. I think it was 1937, it was finished in 1942. When Boulder Dam was built, and these are huge, complicated structures, you had literally 6 formerly competitive companies that formed a consortium. And under that cooperative approach, they were able to, again, create these incredible monuments, epic testimony to the skills and abilities of the engineering skills and abilities and technical capabilities of humans when we stop fighting each other. Friendly competition? Hell yeah, absolutely. Friendly competition is great. But when we start killing each other and throwing potentially nukes at each other, we've gone too far, right? And it's better at that point to, let's say, hey, let's work together because we've got a much larger common goal here where everybody's going to win if we pull this thing off. So I kind of look at now our space, the creating a spacefaring civilization is the counterpart for the generation alive on Earth now to the great cathedral building enterprise of the High Middle Ages. When you had this incredible cooperative effort coming together across France, England, Germany, hundreds of thousands of highly skilled craftspeople, from stonemasons to engineers to astronomers to carpenters to glaziers to sculptors, all of these things were brought together under this incredible, almost miraculous undertaking that we should definitely talk about more, because I really do believe it provides an analog. Because to pull off that incredible epic enterprise of the Gothic cathedral building era, you had to have the entire society motivated and inspired and moved to do this, or it couldn't have happened. Because for every person working on the actual project itself, whether they be stonemasons, sculptors, glaziers, carpenters, engineers, whatever, right, the vast, diverse skill set brought together, for every one person, there had to be 10 people in the supportive social infrastructure to make that possible. So I think that might be a good place to leave it for this episode of Squaring the Circle.
I think so.
I think so. There's a lot more to talk about, and we will as we go forward.
We'll have to talk about Lunar. Do you want to talk about that?
LTPs?
Yeah.
Let's save that. We're talking here.
Next time.
John Arthur's referring to lunar transient phenomenon.
Yep.
Very interesting phenomenon.
And maybe we'll get into some more stuff next time. I'll just tease that there was a lot that we were talking about for this episode. We'll save it for next time.
Okay. Yeah.
It'll be fun.
It's going to be fun. And it was fun seeing you again, John. It was certainly fun being out in the field with you. And I tell you made an impression on everybody, man. How much did that camera setup weigh that you had?
About 25 pounds.
Oh, well, that's not too bad, but it was big and it was bulky. Yeah. And some of those areas we went into, climbing down, climbing up, people were impressed, John. You made a favorable impression on a lot of people.
It was fun.
So we've got that stuff that's going to be coming up. And that is going to be some great stuff. I cannot wait to see it.
We're going to have fun.
What if I told you that the moon has frequently exhibited unexplained activity on its surface? Flashing lights, mysterious fogs, changing colors, ejections of vapor. For centuries, inexplicable visual phenomenon has been witnessed on the moon. What explanations have been offered by scientists for this activity on a celestial body that is assumed to be geologically dead? Is it assumed that this activity is entirely natural in origin? And if not, what could this possibly imply? Join me today as we dive into the unanswered questions surrounding the mysterious subject of transient lunar phenomenon, as well as other curious lunar anomalies on Squaring the Circle. Greetings, everyone. Welcome back to another episode of Squaring the Circle. And I am here today and I'm going to be joined by my friend and colleague, John Arthur. Hello, John. Good to see you again.
Good to see you as well, sir. Howdy, howdy.
Here we are. Yes, here we are. Once again, diving into interesting topics. So far, John, the things we've been talking about together on this program, to me, have been extremely interesting. And it's great to have someone to communicate with about these kinds of topics who has an interest and understands and gets it. So we've got some interesting stuff to dive into in this episode. In the opening statement, I was talking about transient lunar phenomenon, or TLPs. Transient lunar phenomena, or TLPs, are evanescent. Hey, there's a word for us, evanescent. Well, I'm reading this. Why don't you look up evanescent? I like that word. TLPs are evanescent, localized glows and obscurations on the moon. And then it's talking about, mentions three craters, Aristarchus, Alphonsus, and Schroeder's Valley are well-known areas of activity. The emitted light is usually described as reddish or pinkish, sometimes with a sparkling or flowing appearance. The coloration may extend for a distance of 10 miles or more on the lunar surface, with brighter spots 2 to 3 miles across, and is commonly associated with, now this is interesting, veiling of surface features. The average duration of an event is some 20 minutes, but it may persist intermittently for a few hours. No permanent alteration has been detected at the site of any TLP. These phenomena are regarded as distinct from the possible low-level general luminescence most easily detected during a total lunar eclipse. So what did we find for evanescent? I want to add that word to my vocabulary. So somebody says, well, how are you feeling today, Randall? And then I can say, I'm feeling a bit evanescent.
I have an evanescent cold, or I had an evanescent moment of heat exhaustion today, meaning transient or soon passing out of sight or memory.
Well, I don't. Yeah, well, then actually, sometimes I do feel a bit evanescent,
like you're passing out of memory or out of sight.
Yes. Well, there we go.
So transient, something that is passing by. So these are really, really short. Some of them are seconds, some of them are minutes, some of them are hours.
Yeah. Well, here we've got some interesting examples, witness. Now, this one, the first one here, that this was going back to 1787. Famous astronomer William Herschel. So in April of 1787, astronomer William Herschel observed 3 luminous spots on the moon's dark side, interpreting them as active volcanoes. Now, how did astronomer William Herschel observe 3 luminous spots on the moon's dark side in 1787? Interpreting them as active volcanoes. Contemporary research suggests that Herschel may have witnessed the impact of a meteorite, possibly from the Lyrid meteor shower, causing a transient glow due to impact melt. Well, that would certainly make sense. But I'm still not understanding how he would observe 3 luminous spots on the moon's dark side.
I'm sure the account's talking about a partial moon.
It's got to be, yeah.
It has to be talking about that. And so the one thing I find interesting is, by definition, TLPs, they generally say that there's no deformation related to TLPs. But the assumption here is that obviously he saw a meteorite shower or meteorite impact. So that's interesting to me, because they've dated some of these impacts as much older than some of these events, because of our basic understanding of lunar geology. So I'm not sure what to make of that, because again, by definition, TLPs, they want to classify them one way, but then here we see it's potentially a meteorite impact. Don't know. Interesting. Worth noting.
Okay, so now in 1866, Lunar, I remember first reading about this and thinking, well, now this is certainly one of the more interesting examples. In 1866, lunar observer J.F. Julius Schmidt reported that the Linne, Linne with the little mark above it. So that adds an extra syllable, I believe, right? The Linne, but for now, the Linne crater, previously documented as a prominent feature. Hey, why don't you pull that up and see if we can get an image of it?
Yeah, absolutely. So this is from space.com. Let me open this up real quick. And by the way, you're correct. It is the Linne crater.
Yeah, okay.
Let me get that.
What do you call that? Not hypocritical marks.
And throw that up real quick. Here we go.
Diacritical, I believe. Oh, look at that.
So that's the Linne crater.
Linne crater. Okay, so listen to this, what J.F. Julius Schmidt reported in 1866, that the Linne crater, previously documented as a prominent feature, had seemingly vanished or transformed into a mere white spot. This observation sparked debates about lunar surface changes and remains one of the most discussed TLP cases. Interesting. Okay, then we have another case here on November 15th, 1953. Dr. Leon Stewart captured a photograph of a bright flash on the moon, which he interpreted as a meteor impact. Decades later, researchers identified a fresh lunar crater matching the location and timing of Stewart's observation, providing rare photographic evidence of a TLP. So there we go. I mean, so we've got, at least in one circumstances, we have the evidence suggesting that it was in fact a meteorite impact. And then during the Apollo 17 mission in December 1972, astronauts Harrison Schmitt and Ronald Evans reported observing brief flashes of light on the moon's surface while in orbit. These observations added credibility to TLP reports as they came from trained observers in space. Now, my first thought is that a meteorite impact is going to provide a single flash. And if you've got a flashing or multiple flashes, what does that mean?
Number of different question marks are arisen. Are we looking at natural phenomenon? What is this?
I don't know. But let's see. Here's another. This is from the Book of the Moon by Thomas Hockley. And he's asking this question. Is the moon volcanically dead today? Not necessarily, he says. In recent times, there have been some notable claims of observation of activity on the moon. In 1958, Nikolai Kozyrev, who lived from 1908 to 1983. I note there he's born in the same year as the Tunguska event. He was with the Pulkovo Astronomical Observatory in the USSR. He saw a brightening around a crater. He was able to obtain a spectrum of it, which he claimed showed the presence of, get this, carbon-containing gases. Barbara Middlehurst has cataloged this case as well as other reports of transient lunar phenomena on the moon. Barbara Middlehurst. Maybe she has a book. Why don't you, if you don't mind, Barbara Middlehurst, just like it sounds.
So, Welsh astronomer. She lived from 1915 to 1955.
Okay.
Let's see. Oh, she retired to Clear Lake, Houston, the NASAville.
Oh, okay.
Here, so to speak. And see, she was an editor for the Encyclopedia Britannica in this field.
Okay.
Co-editor with Gerald Coupier for Telescopes 1960, the Solar System 3, Planets and Satellites, the Solar System 4, the Moon, Meteorites and Comets.
That's where I know her name from, because I've got that hard book, hard copy, Moon, Meteorites and Comets. Yep, it's right up there on the shelf. So she was the editor of that book, correct?
Correct. Co-editor with Gerard Coupier. It's a Kuiper.
I think it's pronounced Kuiper.
Is that Kuiper?
Yeah, like
really?
Kuiper disc.
Ah.
Yeah.
Looks like a good German name.
Yes. So, John, you actually learned something today.
Kuiper.
I've been a little frustrated in these episodes we've done because you keep seeming like you already know everything. Okay, so that's Barbara Middle. And when did she pass?
She passed away at 95.
In what year?
1995.
Oh, in 1995. So
sorry,
not that
in
long
1995, she was 79. Just missed 80. She just missed 80 years. She was in 1995, born in 1915.
Okay. That's when
so
you
a few
said
years after Tunguska.
Yeah. Okay. So Tunguska, that's kind of like the chronometric standard now by which everything is referred, right?
Before and after Tunguska.
Yeah. Okay, so this was an article that came out in Science News back in 1971 during the heyday of Apollo, right? October 23rd, 1971. Must have been an editor because we're not given the name of the author of this article, but the title is Possible Observation of Water Vapor on the Moon. The presence or absence of water on the moon is central to theories of lunar origin and development. And of course, the whole question of water on the moon is still a very important question, not as much now as far as questions of lunar origin and development, but as far as lunar colonization. After examining returns of Apollo 11, scientists were fairly convinced that there was no water there because of the lack of hydrous minerals, those that contain OH radicals, in the samples. They theorized, therefore, that the original melt from which the rocks were formed had very little, if any, water. The returns from Apollo 12, 14, and 15 seem to support this finding. Now, John W. Freeman Jr. and H. Kent Hills of Rice University in Houston have announced what they believe to be water vapor detected on the moon by the Suprathermal Ion Detector Experiment, or SIDE. Super Ion Detector Experiment. Suprathermal Ion Detector Experiment. Might look that up.
Suprathermal.
Supra. suprathermal ion detector experiment, which goes by the acronym of SIDE, just SIDE.
And pulling it up.
So this was the instrument that they were using. The SIDEs, or suprathermal ion detector experiments, have been quietly measuring, and then in quotes, clouds of low energy ions during the lunar day and before sunrise and sunset. Ions thought to have escaped from the Earth's magnetic bow shock wave, and ions from man-made impacts, lunar landings, and lift-offs. So there could be water vapor, generated by, as it says, man-made impacts, lunar landings, and lifts-off. So the suprathermal ion detector experiment, part of the ALSEP package, measured positive ions reaching the lunar surface, including magnetospheric ions and those generated from ultraviolet ionization of the lunar atmosphere and from the free streaming solar wind/lunar surface interaction. Okay. Flux, number, density, velocity, and energy unit charge were determined for these ions. The scientific objectives of the experiment were to provide information on the energy and mass spectra of the positive ions close to the lunar surface. Okay, measure the flux and energy spectrum of the positive ions in the Earth's
magnetotail.
Magnetotail. Yeah, on my computer, on my monitor, the text is very small. So, okay, well, that kind of gives us an idea. The experiment was housed in a rectangular box, which was deployed on the surface of the moon by the astronauts during their first EVA. A bubble level on the top of the box was used to ensure proper leveling. Well, now that's what we use in our carpentry work. We have a little bubble level. Is that an image over there on the left of the instrument itself?
Correct. Yes, it is. Let me do that real quick.
Okay. Just so we can see what the instrument looks like. This thing was sitting on the moon, and it was this thing that detected the water vapor.
Yep.
Okay. So then let's go on and see what it says. Okay, so it's monitoring. Low energy ions during the lunar day and before sunrise and sunset. Ions thought to have escaped from the Earth's magnetic bow shock wave, and the ions made from man-made impacts, lunar landings, and liftoffs. Okay, so pretty standard stuff. Everybody's okay. This is just what we would imagine it should be detecting. But on March 7th, the instrument saw something unusual at the number 14 site. A very high flux of ions in the spectrum predicted for water vapor. Apollo 12's SIDE also detected the ions. The flux of 783 counts per 1.2 seconds was much higher than anything seen before, more than 100 times greater than that detected when the lunar module vented. Another unusual aspect of the detection was that the flux occurred at the same time that swarms of moonquakes were detected. Rumblings that lasted from 12 to 14 hours. The ion occurrence began shortly after the moonquakes began and stopped shortly after the quakes ceased. Freeman speculates that water vapor could have come from a fissure created by the quakes, and says the findings would not contradict the lack of water vapor in materials found at the surface if the vapor was coming from deep within the lunar interior. So what would that imply or suggest? If water vapor is coming out of the moon deep from within the lunar interior? Well, one of the scientists working on it, lunar scientist Farouk El-Baz, said this: the implications, if the observation is confirmed, are considerable. If water vapor is coming from the moon's interior, this is serious. It means that there is a drastic distinction between the different phases in the lunar interior, that the interior is quite different from what we have seen on the surface. So this was from an article that appeared in Sky and Telescope in 1991, March of 1991, simply entitled Lunar Transient Phenomena. Accounts of lunar transient phenomena, TLPs, are not new. Over the past 30 years, I have collected close to 2,000 observations dating from as far back as 557 AD. Wow. So somebody back there at the early stages of the Dark Ages is witnessing some kind of TLP up on the moon. Most are visual reports of bright spots, flashes, hazes, and curious temporary colorations of the lunar soil. Reputable observers such as William Herschel, Wilhelm Struve, and E. Barnard have seen them. Some LTPs have even been photographed, as well as recorded polarimetrically, photometrically, and spectroscopically. Wait a minute. Spectroscopic. I'll get it. Hang on. Spectroscopically. Spectroscopically. That's a mouthful. Spectroscopically. I'm going to have to practice that one.
Yeah. You practice that one. I'll practice magnanimity, as we were talking about before we got on.
When you said magnanimity?
Magnanimity. Yikes.
Okay. So yeah, I will, it's probably not that critical because we don't use that word that frequently. Yeah. Like that's not a word I use like on a daily basis.
Spectroscopically?
Spectroscopically. Spectroscopically. I think I've got it.
Yeah.
Yet, John, despite a profusion of observations and 6 Apollo missions to the moon, the nature of LTPs remains elusive and their origin an enigma. I like enigmas. They've always fascinated me. Things that don't seem to quite have an ready explanation that you can pull off the shelf. So going on with the Sky and Telescope article, about 200 of some 30,000 lunar features visible in telescopes have been recorded as LTP sources. Half have shown activity only once. Of the remainder, a mere dozen features contribute 3/4 of all reports. One area, Aristarchus, Herodotus, and Schroeder's Valley, is responsible for fully 1/3 of the total number cited. And I believe you pulled up a image of Aristarchus, didn't you?
Yeah, previously. Let me pull it up right now.
And so is Herodotus one of those smaller craters overlapping it maybe?
Let me pull that. I'll start here. And one moment. So here's Aristarchus.
Mm-hmm.
And Herodotus is to the right of it.
I see what that looks like, a long valley extending out of it.
Mm-hmm.
Now that's interesting in the light of our last episode.
It's interesting how the formation has run. Because it's at a curve as opposed to the other two valleys that are a straight shot.
Right.
So this is an oblique close-up.
Oh, look at this.
Here's where you can see it in the night sky.
Okay. Okay.
And then this is a LRO NAC image of the central peak with colors showing variations in the composition.
Uh-huh.
So that's interesting.
That's the central peak. Okay.
This is from the Clementine.
Uh-huh. Okay.
All right, here we go. This is money. Aristarchus, Herodotus. There we go.
Oh, yeah.
Aristarchus B and Z up to the north, U, T, and S to the south, and F and H. For those of you on audio, we'll be putting this in the links to these different images in the description.
Okay, excellent.
And there's one last one.
And that is Aristarchus. Look at that.
This is Aristarchus F. So it's the one that we were looking at right here. Below. I don't know if you're seeing me here.
Hover over it with your mouse. Oh, yeah, there. Yeah. Got it.
So, yeah. And let's go to the... Yeah. So, pretty good.
Yeah.
Some good images there.
Yep. So the Aristarchus, Herodotus, Schroeder's Valley. Ooh, could Schroeder's Valley be that what we saw coming off of Herodotus?
Yes, let me put that back up. Actually, it's just to the north west. So let me see if I can get my cursor here. Here we go.
And that's it up there?
Just a little bit closer here. Here we go.
I got it. Vallis Shrotiri.
So it is a second. It is a second whole impact site. It's not the same. But that's interesting. Is it an impact site? Because you see how the valley actually shifts to the west.
We're taking a little bit of a detour here to tell a story that I think is going to be valuable. I was coming down the stairs, and I think somebody just ahead of me had spilled a little bit. My foot hit it, slid out from under me, and I tumbled down 3 or 4 stairs to the bottom. I sure banged up my left knee. It was painful, but I was very relieved to remember that I happened to pack my CBD from the gods salve. And I was really grateful that I had remembered to do that. So that night I put some of the salve on, went to bed. Though I've being in the construction and building industry, I've had many falls and injuries and stuff, and I figured I'm going to be laid up with this for a month. We drove home. I think it was 3 to 4 days later. I continued applying the salve, and I would say within a week I was getting around pretty good. I always bring the oil when I travel, and I'm now, after this episode, I'm like, okay, I'm always going to have the salve with me too. Next paragraph says that most LTP activity occurs along the edges of Maria, near volcanic features like domes, sinuous rills, and craters with dark halos or floors. But these regions, like the rest of the moon, have long been considered geologically dead.
But here's the thing. I looked it up. Vallis Shrotiri is believed to have been formed by volcanic activity.
Oh.
Says Peter Wolczuk from Observing the Moon. His book in 2000 he published.
Aha.
So we're starting to see maybe there is some volcanic activity on the moon.
Mm-hmm. But the thing is, though, okay, so when we talk volcanic activity, What time frame? Are we talking about this is something that would have happened millions, hundreds of millions, billions, according to the standard chronologies? Or is this something, I mean, because we're looking at the TLPs now we're looking at are, within the, well, it's said, I think we got the earliest one we had quoted here was 550 something. Yeah.
Yep.
Okay, so now here's another one. On January 24th, 1956, amateur lunar observer R. Houghton was drawing the crater Liebig, Liebig, on the edge of Mare Humorum. Well, this ought to be interesting. When something bright flashed in the field of his 7-inch telescope. The flare came from the nearby crater Cavendish, which was just emerging from the lunar night. Closer inspection revealed that a peak on the crater's eastern wall was repeatedly flashing. Houghton called astronomer Brian Warner and told him what to look for. Warner, too, saw the flashes and called them so conspicuous that they were seen immediately. The other peaks in the vicinity remained normal. So it was actually then, the flashing came from the crater Cavendish, starting with a C, Cavendish.
Yes, sir. It's right here. Wait, let's do this. There we go.
Cavendish. So I suppose that's the larger crater.
Mm-hmm.
Something that's interesting here that, just sort of an aside, when you see these overlapping craters, what that kind of has allowed astronomers to do is to establish a relative chronology, not absolute, but relative, which simply means that the smaller crater is younger than Cavendish. Why? Because it breaks and superimposes itself on the rim. Whereas if Cavendish was the younger crater, its rim would remain intact, and you would only see like half of the smaller crater. That makes sense, doesn't it?
Sure. Absolutely. And then this is Liebig. Again, for those of you on audio, just check out the comment or check out the description. But this is Liebig.
Liebig on the moon. Okay. On the night of November 2nd to the 3rd in 1958, Soviet astronomer Nikolai A. Kozyrev witnessed a strange phenomena while making spectrograms of the crater Alphonsus with the Crimean Astrophysical Observatory's 50-inch reflector. The crater Alphonsus. So that's a Alphonsus. As he watched through the telescope's guiding eyepiece, he saw the crater's central peak blur and turn an unusual reddish color. The spectrograms confirmed his visual impressions of a volcanic event. They show an emission spectrum of carbon vapor. So there we go, carbon vapor again. So there's the crater's central peak. Very obvious in this one, isn't it?
Correct.
Right? Central peak, blur and turn an unusual reddish color. So, okay, what? Okay, so a volcanic event that's spewing out carbon dioxide from the central peak of this crater? What's going on? Carbon vapor. What does that seem to imply?
Good question.
Okay, then on July 19th, 1969, the Apollo 11 command module had just achieved orbit around the moon when the Mission Control Center in Houston, Texas, received word that amateur astronomers reported transient phenomena in the vicinity of the crater Aristarchus. So Aristarchus seems to be a hotbed of TLPs. Asked to check out the situation, astronaut Neil Armstrong looked out his window toward the Earth-lit region and observed an, quote, area that is considerably more illuminated than the surrounding area. It seems to have a slight amount of fluorescence to it. Fluorescence. So what is fluorescence? Fluorescence. Fluorescence. Looks like a lower, just as Herodotus here looks like is then emerging from the lunar night. And what is this coming up this way here?
That's going to be Valles Schrotteri.
Okay, okay. And so that seems to be somehow associated with these craters.
And again, Valles Schrotteri is associated with volcanic formation. Not sure, but that's the current hypothesis on deck.
This is from an old journal from Scientific American way back in the early part of the 20th century. John A. Cook is asking, is the moon a dead world? So far as can be ascertained by the most careful examination, not the slightest change ever takes place on its surface. Thus wrote one of the world's greatest astronomers, Simon Newcomb, in Astronomy for Everybody, page 128, published in 1910. This appears to be the consensus of opinion among astronomers. Notwithstanding the evidence that the crater Linnaeus was, prior to the year 1866, a 6-mile crater, very deep, visible under all illuminations, and that in that year it became invisible for some months, seemingly concealed by a fog or haze that hung over it. And upon clearing up, a much smaller crater was in its place, and surrounding it a white spot like a drop of whitewash on the dark sea floor, occupying the space of the original crater. There we go. This map is based upon a survey of 300 TLPs by Barbara Middlehurst and Patrick Moore. Shows the approximate distribution of observed events. Red-hued events are in red, the remainder are in yellow. So every red dot that you see was a TLP that had a red hue to it. The description, this map displays an approximate distribution of transient lunar phenomena. It is based on a monochrome map by Barbara Middlehurst and Patrick Moore that was published in the book On the Moon in 2001. Red dots indicate TLP that appeared to the observer as a reddish cloud. Yellow dots are all other events. You've got that interesting video of some of the events. I think maybe we should take a look at that.
And again,
there it is, yeah.
From the lunar surface, you can see, if you're on audio, you can see a bright flash that's very short. Mm-hmm. This is a black and white, effectively, image here. So we don't know the hue, but it's very bright.
Yeah, I see it.
Leonid. And Gemini D. Where are we? We just missed it. Here we go. It's very faint. So if you're watching, you can see what we're talking about here. Let's go a bit further. And at the bottom of the screen, thank you. I know you're sharing. I don't need to see the sharing screen. There we go. There's our little dot.
Oh, right down there.
Play.
Bottom center, right?
Correct. Bottom
right
center.
Right at the edge.
And then scroll just a bit further. So in the green box, you see that little itty bitty light. What's going on there? It's interesting. And then we have another one in the green box, bottom right.
Okay, just caught it. It was small, but I saw it for a second. Yeah.
It's a flash in a pan. And then they have this UFO caught. Now, we were talking, is this an aircraft or what? This is at the Alamo. We looked that up before we started tonight, and it's a 14-inch optic. So it's a 14-inch element in the bottom of the telescope. So the main light gathering source.
Would you capture an image like that? Let's say it's an airplane in the atmosphere. Are you going to catch that in this? I mean, when we're looking at something that's 250,000 miles away.
I know. It's strange.
Where is this object within that? In the depth of field? Is it near to the camera? Is it out there? Yeah. I mean, what the hell is it?
Yeah,
explain that to me, John.
You would think it would be much, much larger if this was an aircraft in atmosphere. You would think, but someone who's much smarter than I am and has actually lots of experience with optics might be able to speak to that. If you know, hey, drop that in the comment section. What do you think? You think that's an aircraft or is it something else? So looks to me like an aircraft, but the perspective is odd. You would think it would be much larger in the element.
Well, yeah, because if it's close up, I mean, obviously the width of this thing here is you're encompassing what here, 1,000 miles from left to right within the image. Yeah, and then so, this is going to be closer. If this is closer, obviously it's closer, but if it was in, say, the Earth's atmosphere, you would think wouldn't it pass through the frame so fast we wouldn't even? Yeah. I mean, I don't know. This is weird. It is a very interesting video. Can we watch the video of just the part where this thing is flashing through the field of view? That fast. Do it again. What in the hell is? Yeah. Huh. So it's interesting, and this is how fast it goes. There we go. Just in, a matter of a second or two, it's across the frame. But it's quite a few frames for something that would be in atmosphere. That's interesting. So, but we have all these small transient phenomena, these little blinking lights, these flashes, and some of them are happening in the same place. Which now we know that the moon is not one homogeneous chunk. It's porous. Yeah. We talked about last week. It's what it appears. And we'll get into that in just a second. Well, before we segue, we got that one last case that's very interesting to me. This was the record of Gervasi of Canterbury. He was an English monk and historian, and he's citing the eyewitness account of 5 monks on the evening of June 18th, 1178. So what I'm going to read here is translated directly from the Latin. Now there was a bright new moon, and as usual in that phase, its horns were tilted toward the east. Okay. And suddenly, the upper horn split in two. From the midpoint of this division, a flaming torch sprang up, spewing out over a considerable distance fire, hot coals, and sparks. Meanwhile, the body of the moon, which was below, writhed and throbbed like a wounded snake. So what were they witnessing? Well, let's see. It was Jack Hortung. Jack Hortung suggested that possibly it was an impact that produced Giordano Bruno crater. Pull up an image of that once. And one reason why now that's been disputed. Others have thought that Bruno crater was too old. I don't have an opinion on the matter. However, relatively speaking, Bruno crater is young. And one way that you know that it's young is because the galactic cosmic rays haven't caused the ejecta blanket to darken. The ejecta blanket is very light. Yeah, like you can see right there. Yeah, look at that. That's crater Bruno. I think it's about 20 miles in diameter. And it's a very relatively young crater. So Hartung proposed that it seemed to be about in the right place one would expect it to be, but whether Bruno crater is or isn't the cause of what these 5 monks witnessed, they obviously witnessed something. And I would think that it sounds to me like it was probably some type of an impact event, being June in June, and that would have been that would have actually, when you adjust from the Julian to the Gregorian calendar, this comes very close to being the peak of the Taurid meteor shower. So this could have been, I think this has actually even been proposed, this event, as being an impact of a Taurid meteor on the moon in 1178.
And that's what I was alluding to earlier. Some of these are dated. Some of these craters are dated much older than supposedly human dwelling on the Earth is by the typical geological, historical concept. And then this one, I don't know. It's interesting.
Yeah,
it'd make a lot of sense.
And I think you just reminded me of that word that I was looking for earlier, and I couldn't think where sometimes you hear quite frequently people substituting the letter B or inserting the letter B. So I've got to get this off my chest, if that's okay.
Okay. So there's a word that Randall hates it when people insert a B into this word.
Yes. The word is supposedly.
Supposedly.
And supposedly, the way you pronounce supposedly is supposedly. However, I quite frequently hear people pronouncing it supposably.
I didn't say supposedly, did I?
No, not you, John. Because if you did say that, John, I think I would immediately have to be seeking a new co-host, new producer. Yes,
I think so.
But
supposedly you would.
Supposedly, I would find a new producer. Yes.
Someone is typing a comment right now. Hey, I say it that way.
No, okay, well.
Don't.
So, supposedly, there's a ratio between crater width and crater depth. This is one of the early books, one of my favorites, back when I really started diving into this stuff, kind of semi-seriously. Zdeněk Kopal in 1979 wrote a book called The Realm of the Terrestrial Planets. And he's talking about the number of craters on the moon. He says the number of craters on the moon is indeed immense. Those with diameters in excess of 1 kilometer are estimated to more than 300,000 on its visible hemisphere and to at least 1 million on its far side. Those smaller still number too many for any realistic estimate. There are 16 formations of the type enclosed within unbroken walls with diameters in excess of 200 kilometers. The crater Clavius, near the moon's south pole, is one of them. And I think we were looking at that a little earlier, weren't we? The crater, I believe it would be Clavius, not Clavius.
Clavius is correct.
Okay.
1 second.
That's Bruno.
There we go.
There it is, yeah. Notice how, okay, there, yeah, how you got these smaller craters juxtaposed on the rim of the larger one, which, immediately tells you that they're obviously younger. All of those craters in the middle, the smaller ones that you see there, they're obviously formed. So Clavius, right? We agreed it was Clavius. So Clavius formed first, and then subsequent to the formation of Clavius, you had all these younger craters that were formed.
And the ratio you were looking for earlier is 1.1 to 0.11 to 0.20, I believe. The diameter to depth. Diameter to depth.
Say that again. I want to.
So let me pull it up. 0.11 to 0.20. The diameter will multiply the diameter by
0.20 would be the diameter, right? And 1.1 is the depth, because obviously the diameter is greater than the depth.
So no. So you're in a range. So your depth will be 11 to 20% of the diameter.
Yes, got it. What? Say the number again, right? So it's
0.11.
0.11. So let's say we have a crater that's 12 miles in diameter times 0.11. Its depth should be 1.32 miles. Or that's at one end of the spectrum, and the other one was 2 point something.
2.0. So it would be
just times
2.4 miles in depth.
In depth, right?
Yeah.
Okay. Thank you for that. I knew that. I just didn't understand what you were saying.
Yeah.
So
I apologize.
It's okay, John. I forgive you.
Forgive me. Thank you.
Yes. Right. But you're gonna. I expect you will be doing much better in the future, right?
Absolutely.
Okay. All right. So 0.2. So we're basically saying, if we're using 0.2, that's easy, because now we're saying the width is 5 times the depth.
Correct.
So a 10-mile crater, 2 miles wide. 10-mile wide crater, 2 miles deep. 20-mile crater, 4 miles deep. Right. Got it. So he's talking here in the realm of the terrestrial planets. He says there are 16 formations of the type enclosed within unbroken walls with diameters in excess of 200 kilometers. Okay, so if we go, I like to think in miles, so that's 120 miles. If I go times 0.2, that's a depth of 24 miles. The crater Clavius near the moon's south pole is one of them. Over 70 craters, 32 of which are visible from the Earth, possess diameters between 100 and 200 kilometers. These are usually characterized by fairly smooth floors, sometimes checkered by smaller craters, such as, for instance, Clavius, which are again absent in others. The elevation of their walls, 1 to 3 kilometers, represents so small a fraction of their dimensions that even their rims are mostly below the horizon for an observer situated at the center. And I have a graph here of a number of these craters. And you see the scale bar at the bottom. So like Alphonsus, right? That looks to be darn close to maybe 80 to 90 miles in diameter. But again, what seems to happen here is that the classical scaling ratio, diameter to depth, seems to hold until you get up to 18 or 20 miles, right? But then crater diameter continues to increase, but crater depth does not. Okay, so what's going on here? Like down here, so we see that Alphonsus has a central uplift peak. Archimedes does not. But if Archimedes, looking at this scale bar, it looks like Archimedes is roughly 50 miles in diameter. So 50 times 0.2 then is going to be 10 miles in depth. It should be a hole in the lunar. Now, I don't know if that's the original depth of the crater, or does that include the fallback breccia that infills the crater and usually makes the final crater shallower than the transient crater when all this stuff has been excavated, but before it's infilled back in?
Let me see here.
Look at the crater Plato. So now look at the cross section of Copernicus there. What you can see there is their central uplift, and then you're seeing the two flanking peaks. That would be the cross section of a central ring. You can see the Tycho has a central uplift, and so does, would it be Theophilus? More so than Theophilus? I think it would be Theophilus, is what I'm guessing. Now on Earth, the infilling, there's definitely a distinction between the three things. The maximum depth, which would be what's called a transient crater. Then in the immediate aftermath, after all of the fallback material and slumping has infilled a crater, and then over time, oftentimes you'll have some rebound and subsequent also infilling. So in the immediate aftermath of in those first few seconds of impact, that's the maximum depth. That's the transient crater. Then you would have, in the days following, weeks following, years following, you'll have the second stage, which has had the material falling back in, because there's probably a lot of instabilities. Now this is on Earth, you're going to have slumping and stuff, but on the moon as well. It certainly has been observed on Mars, and this is going to infill the crater. And then over long periods of time, you're going to have more sediment accumulation and possibly some more rebounding, vertical movement upwards. So the final depth of the crater may not be close to what the original depth was. But here, like looking at Archimedes and Plato, okay, so you got a 50-mile crater that should be 20 miles deep, or 10 miles deep, rather. But where's the material that would slump into it? I mean, and is there rebound? Was it originally let's see. So let's say 50 miles deep times, so that's 10 miles deep.
So,
but how deep is it? A few miles. So correct. Is there infilling? If there's material infilling it, is that the case?
Well, so here's what they say on this article for impact cratering mechanics and crater morphology. So the depth of a crater is considerably less than the diameter. For example, simple craters on the moon have a depth diameter ratio of 1.4 to 2.0. That's where we got it. The diameter is 5 to 7 times greater than the depth. For complex craters on the moon, larger than 20 kilometers, the depth diameter ratio ranges from 0.1 to 0.05. That's what I was reading a moment ago. The diameter is from 10 to 20 times larger than the depth. This is because of the slumping of the inner walls and formation to the central peak causes a shallower depth. But here's where this is what I think is necessary here. This to understand the strength of the shockwaves is so great that the rocks are subjected to enormous pressures. The interaction of the shockwaves with the unconfined surface, called a free surface, is responsible for excavating the crater. After passage of the shockwave, the compressed rock snaps back along the free surface. This produces a tensional wave called a rarefaction wave.
Okay.
That decompresses and fractures the rock, setting it into motion along the fracture planes. The net effect is to momentarily convert the rock into a fluid-like material that moves laterally upward and out, a steady-growing excavation cavity. In the meantime, the projectile has been largely destroyed by the shockwaves that generated it. So you have some rarefaction that occurs to the Earth, or to the moon in this case.
Yeah.
So I think that's why, especially with those larger craters, you actually have a momentary rarefaction, or I would use the word liquefaction, but it would be incorrect. But you have this moment of sand being shooken by just the intense slapback wave.
Sure.
And allows it to kind of settle.
I've got an aerial view of Meteor Crater, the famous one. I think this is wrong. I think there's been some discussion, and at one point it was dated to 26,000 years, but I think it's gone back to being closer to 50,000 years. But the age is not the important part here for this discussion. It's the ratio of width to depth. So you got 3/5 of a mile, so 5,280 divided by 5 times 3 will give us 3,168 feet in diameter, right? And its depth, what did it say? 600 feet deep. So we divide that by 600, and then we invert that. So we're looking at about 0.19. Right here's the ratio. Fits right in.
Right in the zone.
Right, yeah. Now, let's look at some of these lunar craters, like Mare Serenitatis, right? It's almost flat. I mean, and presumably it's a crater. And you got another one here, one of the mares. Here's Theophilus, which is this right here. And you can see the smaller craters. You can see here, they look just from visual appearance like they're fitting the ratio, and they've got central uplifts. There's no central uplift in Theophilus. And here's Alfonso right here. Another view of Alfonso. And look at this, must be, Ptolemaeus, which is this, is the lower left. So you've got Ptolemaeus, Alphonsus, and then, the Aristarchus, Herodotus was next to Aristarchus. So I don't know what this crater is up here. But look, what it's striking me is that from this is that once you get to Alphonsus, you're kind of at that transitional stage where diameter continue to enlarge, but it doesn't get any deeper.
0.05, so 5% to 10% of the diameter at that size.
Yeah. In the book, The Moon and the Planets, a catalog of astronomical anomalies by William R. Corliss, in 1985, he had a heading in there, a contribution entitled Apparently Anomalous Long-Term Persistence of Craters. So he's talking here about, quote, an apparently unresolved paradox. The science of rheology, Rheology. The science of rheology deals with the flow of solids under stress. Equations describing the deformation of solids under the influence of prolonged forces such as gravity are well developed. That terrestrial rocks can deform in relatively short periods of time can be seen in the movements of salt and ice glaciers and the sagging of old tombstones under their own weight. The thrust of this article is that the moon's crater walls must flow like any other solid. In fact, after 3 or more billion years, the lunar craters should all but have disappeared. The unit of did you find a definition for rheology just to help us get?
Rheology is the science that studies the flow and deformation of matter, especially materials that exhibit both solid and liquid characteristics. It focuses on how materials behave when subjected to forces, including their ability to flow, change shape, and respond to stress.
Okay. Because I encountered the term quite frequently when I'm trying to understand the distribution of mass in the Earth that takes place between glacial and interglacial transitions. So this goes on. The unit of viscosity, and that's you could say the sluggishness of it. Like if you have a glass of milk and a glass of molasses, The molasses is, you pour them both out. The molasses is going to take much longer and slower because it has higher viscosity. And the unit of viscosity is the poise, P-O-I-S-E, right? Viscosity. So terrestrial rocks have viscosities well under 10 to the 23rd poises, or poises, I guess. So granite, for example, is 10 to the 20th poises. Look up poises for us.
So it was poise is a measurement named after Jean-Marie Poiseau.
Poiseau.
Poiseau, okay. I guess is how you would say his name. It's a Poiseule. It is defined as the viscosity of a fluid where a shear force of 1 dyne, that's D-Y-N-E, per square centimeter is required to maintain a velocity difference of 1 centimeter per second between two parallel planes 1 centimeter apart.
Okay, so we're talking here about viscosity and how the unit of measure. We don't necessarily get into the scientific definition of a poise. Simply, it's just a unit of measure to determine how readily a material will flow under pressure. Whether that's gravity or some other externally applied pressure. I would suppose, since they're using granite as an example of 10 to the 20th poises, that would be granite tested in some laboratory in some type of a machine that would determine at what point it reaches its elastic limit, I'm guessing. So the unit of terrestrial rocks have viscosities well under 10 to the 23rd poises. For example, granite is 10 to the 20th poise. By analogy to terrestrial rocks, lunar rocks should be under, or the rocks composing craters should be under 10 to the 23rd poises also. Lunar basalts, for example, are very much like terrestrial basalts. So using the equations of rheology, the lunar craters should be flattened by gravity in less than 1 million years if the viscosities of similar terrestrial rocks, such as basalt, are used. Actually, some scientists have estimated the viscosity of the lunar crust at 10 to the 27th power poises, based on the assumption that the lunar crust solidified over 3 billion years ago. In contrast, the viscosity of the terrestrial mantle is usually taken as 10 to the 22nd poises, so this is a factor of 10 to the 5th lower. So in other words, 10 to the 5th lower, what is that? That's going to be 100,000. 100,000. So in other words, the craters seem to be 100,000 times more rigid than you would expect to find equivalent craters on Earth composed of the same material. I think that's what this is telling us.
That's based on the dating metric.
So what the heck is going on there?
Either the dating metric's wrong or the moon is very, very hard.
Very.
They're new.
Or they're new.
Or they're new. They're newer than 1 million years. So, which again would be the dating metric would be there'd be something wrong with our current understanding of the moon.
Something is not quite adding up here. Yeah. Well, then there's something else. The seismic signature of observed moonquakes. This is also now from the realm of terrestrial planets, same book. The seismic signature of the observed moonquakes is very different from that of terrestrial earthquakes. Whereas seismic disturbances on Earth are damped out in a matter of minutes, the aftermath of lunar tremors persists for 60 to 100 minutes or even longer. Such long echoes can be caused only by an extraordinary amount of scattering of seismic waves in a highly fragmented surface layers, about 20 kilometers deep, in which compressional waves propagate with a velocity of about 7 kilometers per second. Below approximately 60 kilometers, this velocity increases quite abruptly to 8.1 kilometers per second, no doubt as a result of a corresponding change in composition. But I find this interesting. Now it's from there, and then remains the same from there down to at least 1,000 kilometers. So it says here, long echoes. Echo. I'm thinking an echo. We're talking about echoes reverberating within the moon. Echoes. How do you generate echoes? Have you ever been able to produce an echo?
Yeah. You find somewhere where it's hollow and you speak into it, whether it's a canyon or a valley, somewhere where there's a lot of space, and it takes a while for that to come back.
Back in the early 80s, I started a drum circle, and my leading student, my old friend Jerry, who played in the band with us, he had a little shop outside in Atlanta, a place called Little Five Points, and there were, buildings. They were about 2 stories tall, but when there was no traffic, you could actually get an echo. And we discovered that when we were drumming, the sound would be bouncing off the building across the street with this slight little delay, which was really cool because it was almost like you were playing with multiple drummers and you were syncopating your drumming, right? But yes, I mean, the first thing that come to my mind, of course, is a canyon. Where were we? Just on the tour, we were finding some echoes. Where was that? Was that?
It wasn't Bruneau. It was the one right before Bruneau with all of those wonderful rocky banks. It was. I'm trying to remember. It was in the Raptor Preserve.
Oh.
And Wiley, right? Wiley.
Wyatt
was
yes.
Echoing. Yeehaw or wahoo.
Yes, okay, that's right. Wyatt traditionally does that on every trip. We hear hollering and whooping, echoing off in the distance, and we know Wyatt.
See, I got you doing it now. I'm sorry.
Yeah, Wyatt. So, okay, this is interesting. However, an analysis of seismic data furnished by moonquakes with epicenters on the moon's far side has shown that for seismic events emerging from depths greater than 1,000 kilometers, which is less than 700 kilometers from the moon's center, shear waves cease to leave any discernible trace in seismic messages recorded on the surface. So that must suggest that that zone from 700 kilometers, which is about 450 miles, maybe, from the center of the moon, there's a zone in there where you have this echoing phenomena.
Some would call that interesting, worth exploring.
Yeah, and here I have a graphic to show some of the seismic signatures of 3 lunar events recorded by Apollo 12 seismometer in 1969. The top event is the crashing of the lunar module. The 2 lower ones are caused by natural moonquakes. Look at that middle one. I mean, that's just echoing and echoing on. Looks like, I wish what the horizontal axis is here. Right here. What is that? 10 minutes.
10 minutes. Wow.
So this is, looks like a couple of hours. The thing is ringing.
It's like you threw a rock on a tank like an empty diesel tank, 1,000-gallon tank, and it just was reverberating for an hour.
When you first said tank, I'm thinking like a Abrams tank.
No,
out in the middle of. But I got you. Yeah.
The thing about so we've got an ag tank on our property. That's 1,000 gallons of diesel. When that sucker's empty, you throw a rock on it.
Yes.
It'll sit there for 2 or 3 minutes.
Yep. Yeah, I remember that well because at my grandparents' house in Minnesota, they had a fuel tank in the basement. And exactly the same I discovered as a little kid that, when usually at the end of the winter when it was pretty empty, I could go in there and I could beat on it. And yes, it would echo and reverberate. I definitely remember that very clearly. So, yeah, there we go. What's going on here? Well, let's get back into some commentary to see if we can get some clues. So the seismic phenomena just described leave, and you, consistent with what you commented, the seismic phenomena described leave no room for doubt that our initial assumption of a homogeneous moon cannot be true. It cannot be true in detail, and that the internal density is likely to change with each change in the velocity of propagation of seismic waves. Now let's pause for a minute. We talked about, I think this was while we were recording the episode, right, that if we look at a lunar rock from the surface was 3.34 grams per cubic centimeter, right? I don't
think we covered that on so go ahead and just rehash that really quick.
Yeah, okay, let's rehash that. So let me back up a little here. Next to its size, that's the primary physical characteristic of the moon, but next to its size, the second physical characteristic of the moon, which is of fundamental importance for its structure, is its mass. The mass of the moon, like that of any other celestial body, which cannot be placed on our terrestrial scales, can be determined only from the effects of its attraction on another nearby body of known mass. In the case of the moon, this has first been the Earth, and then in the more recent past, different types of space probes. Now, this is being written in 1979. The ratio of the mass of the Earth to the mass of the moon, of the Earth-Moon masses, was found from such work to be equal to 81.302. So in other words, the Earth is 81.302 times the mass of the moon. Or in round numbers, it's 81 times as massive. And since the mass of the Earth is known, that of the moon comes out to be 7.350 times 10 to the 25th grams, or more than 73 trillion tons. Now, there's a trivia for you. If you're ever in a trivia contest, John, and the question comes up, how much does the moon weigh? You can say, you can raise your hand, you can go 73 trillion tons.
Got it.
Wow. Okay.
This is that in 5th grade.
Yeah. This is the weight of our nearest celestial neighbor, and although it may loom incomprehensibly large for the reader accustomed to terrestrial weights and measures, on a cosmic scale it constitutes only a relatively modest lump. And nor is the mean density of the lunar globe unusual. Well, that we're going to require some qualification in a minute. If we divide the lunar mass by its volume, 2.199 times 10 to the 25th cubic centimeters, we find that its mean density is equal to 3.34 grams per cubic centimeter. So in other words, the standard is 1 gram per cubic centimeter is water. I think, taking it I don't know, probably what temperature? Room temperature, I'm guessing. That's about the same as basaltic rocks in the Earth's crust. And if you go out and you pick up a standard rock from the side of the road or side of a creek or river, it's probably going to be right very close to that range, 3.34 grams per cubic centimeter, or 3 1/3 times more dense than water. Okay. And it's going to be, and here's the important point, it's going to be considerably smaller than the mean density of the terrestrial globe. So in other words, let's clarify what we're talking about here. You pick up a surface rock on the Earth, and it's going to have a mean density of around 3 1/3 grams per cubic centimeter, which is a whole lot smaller than the mean density of the Earth. Put in, let's see, what is the mean density? Mean density of the Earth. I'm going to guess it's, probably in the high 5 point something, close to 6 grams per cubic centimeter, maybe?
5.51, so right on.
5.51 grams per cubic. Now, that's the mean density. So you figure surface 3.34, the center of the moon has to be a lot more dense in order for the mean density to be 5.51. Okay?
Yep.
So if you pick up a rock on the surface of the Earth, what you find is that its density is way less than the mean density of the Earth as a whole. Okay. Well, here's the problem with the moon. The mean density of the moon is about 3.34 grams per cubic centimeter. So what would that imply? Well, would that imply then that the moon is homogeneous? See? Well, if you go and if you dig a hole to the center of the moon and you start taking scoops of lunar material, well, if the mean density is the same throughout the whole mass of the moon, is the same as the mean density of material you pick up on the surface, well then, do you assume that that it's homogeneous, that it's the same material throughout? But that poses problems, doesn't it? Does that make sense if you go, oh, well, then the very core of the moon is no denser than 3.34 grams per cubic centimeter? Does that make sense? Well, let's see. For the moment, it goes on. For the moment, let us abandon the global properties of the moon and turn our attention to its interior. The primary clues to its structure are already in our hands, namely its known mass and size, combining in a mean density of 3.34 grams per cubic centimeter. The average density of lunar rocks brought back from the moon between 69 and 72 by Apollo 11 through 17 missions ranges between 3.1 and 3.5 grams per cubic centimeter. Just right in the range of terrestrial rocks. Well, this coincidence becomes even more convincing when we recall that densities of 3.1 to 3.5 grams per cubic centimeter are those of their material at zero pressure, while the mean density of 3.34 grams per cubic centimeter refers to matter compressed by self-attraction. So here's what he's getting at. Well, what doesn't seem to add up here is that, of course, the overall density of the moon is going to be the same as the surface of the moon, which is material at zero pressure. So it's almost as if the whole composition of the interior composition of the moon is at zero pressure, but that doesn't make sense because you've got matter compressed by self-attraction. So now you got the law of gravity, which would completely seem to contradict the notion of a homogeneous moon. But there we go. So the moon is basically a very low density object. So now, what does that mean? Well, we found out that craters aren't obeying the laws that we would expect, right? And Then we have the seismic signature of observed moonquakes, which suggest what?
Porosity.
Porosity. So then, now let's come back to this. So the seismic phenomena described leave no room for doubt that our initial assumption of a homogeneous moon cannot be true. It cannot be true in detail, and that the internal density is likely to change with each change in the velocity of propagation of seismic waves. Then, here we get to the perhaps the crux of the matter. We also possess irrefutable evidence that the distribution of mass inside the moon is not strictly radially symmetrical. A sufficient proof that the moon does not conform exactly to a spherically symmetrical model has been provided by the familiar phenomena of synchronism between rotation and revolution of our satellite. In brief, by the fact that the moon continues to show us the same face. If its mass, now get this is critical. If its mass were distributed concentrically throughout its interior, its gravitational potential would be equivalent to that of a mass point. But if this were so, the terrestrial attraction would be powerless to exert any effect on its motion, and the moon could rotate at any speed about an arbitrary axis. So that familiar synchronism between rotation and revolution, what is called one-to-one spin-orbit coupling, suggests that the moon is not behaving as radially distributed mass. Yet the moon's mass of 73 trillion tons is such that the rheology of the moon should allow it to settle out to a radial distribution about its center of mass. So coming back to the Apollo seismic experiment, the team that was conducting that experiment reported, now this is from 1970, it's from the journal Science, it's entitled Missile Impacts as Sources of Seismic Energy on the Moon. The Apollo Passive Seismic Experiment team has recently reported first results from the impact of the ascent stage of the lunar module on the lunar surface as part of the Apollo 12 mission. Seismic energy from the impact was recorded by the seismometers deployed on the lunar surface by Apollo 12 astronauts as part of the in-place science station called the Apollo Lunar Surface Experiments Package. The impact experiments have emerged as an extremely powerful tool in the seismic exploration of the moon. The purpose of this report is to aid in the interpretation of the lunar impact signals by presenting seismic data recorded from missile impacts at White Sands Missile Range. Seismic signals from a total of 5 missile impacts were recorded between early 68 and 1969 at White Sands Missile Range, New Mexico. So what were the results of this experiments by looking at seismic signals at White Sands Missile Range compared to the results of impacts on the moon? The lunar module impacted 75.9 kilometers from the Apollo 12 lunar seismic station in the Sea of Storms. The signal recorded by the long-period vertical component seismometer is strikingly different from that of the missile impact signals, the ones at White Sands. Well, we were kind of starting to suspect that, weren't we? As described by Latham et al., the duration of the lunar module impact signal is extremely long, approximately 55 minutes, in comparison with the missile impact signals, which at a range of 79.9 kilometers would have lasted several minutes at most. The LM, or Lunar Module Impact Wave Train, has a very emergent beginning, builds up slowly to a maximum over a period of 6.8 minutes, and then gradually decreases in amplitude. The attenuation of seismic waves that propagate through the outer regions of the moon is extremely low compared with the attenuation observed for propagation through the crust of the Earth. As one hypothesis to explain the unexpected character of the lunar module impact signal, Latham and others suggest that the moon not only has a high Q, or quality factor, we don't need to get into what that is, but it is also very heterogeneous. What is the definition of that term?
Something that's composed of different components, not homogeneous, but
not homogeneous.
Genius.
Yes, very heterogeneous. The nature of this heterogeneity, if indeed this interpretation of the data is correct, has important implications relative to the origin and evolution of the moon. The complete lack of similarity between the lunar impact signal and the signals from the missile impacts reported here supports the view that the structure of the moon in the vicinity of Apollo 12 landing site is radically different from the typical crustal structure of the Earth. This is from A.E. Ringwood, 1979, The Origin of the Earth and Moon. So what do we know now about the structure of the moon from lunar seismograms? Well, we certainly could not take any chances when it came to providing the necessary sources for the lunar seismic network. If the moon were totally inactive seismically, we would have to generate some large artificial seismic sources ourselves and rely on these to probe the moon. Fortunately, it did not take much energy to adjust the trajectories of the discarded Saturn V third stage boosters in order to guide them towards pre-selected impact points on the lunar surface. But these were not the only artificial projectiles to be used as seismic sources. After the landing phase, each lunar module ascent stage was jettisoned and crashed onto the lunar surface as soon as its two astronauts had safely transferred back to the orbiting command module. But boosters and spent lunar modules have not been the only projectiles to hit the moon in recent years. There have also been several large meteorite impacts, several of which occurred at considerable distances from the seismic network, some even on the far side. So how thick is the lunar crust, and of what does it consist? Well, perhaps the most intriguing aspect of all lunar seismograms is that they last for so long. In some cases, seismic waves are still being recorded a full hour after the first primary wave arrived. In other words, the moon rings like a bell when it is struck.
Ring a bell?
Does that ring a bell, John?
I remember these.
And that's not just any bell, is it?
No, that's the Liberty Bell.
That is the Liberty Bell. Yes.
I touched it back when they still allowed you to get near it.
Oh, really?
Yes.
So it really does have a crack in it, doesn't it? So if there were carbon gases or water vapor, some such thing being generated inside the Liberty Bell and you closed off its bottom, it would probably come out that crack, wouldn't it?
Probably would. Yep.
Mm-hmm. Okay. So that's a replica of the 1976 commemorative bicentennial silver dollar. I thought that was interesting. Little juxtaposition.
Yes.
Yeah.
Okay. So Randall, don't beat around the bush. What exactly are you saying?
I'm just taking note of the moon Now, the next thing we need to explore is mass cons, and I think we should save that for the next episode.
I think so.
Mm-hmm. You know what a mass con is?
A mass? So,
okay. MASCON.
Okay. I don't.
A mass con. It's a contraction of mass concentration.
Got it.
Aha. And where we'll leave it is that mass concentrations were discovered in the early days of exploring the moon in preparation for the Apollo landings. And so they sent up a series of lunar orbiter missions. And this is written in 1968, okay? It appeared in the journal Science, lunar mass concentrations. So the lunar orbiter missions have provided both high-quality photographs of the moon and supplementary scientific information concerning the gravitational field of the moon. Previous investigators have concluded that the moon was gravitationally rougher than anticipated. This roughness of the moon has been of interest to the Apollo project because of the resulting perturbations on the trajectory of the Apollo orbiting spacecraft. For these reasons, a new analysis has been done with the use of the accurate tracking data received here by the NASA Deep Space Network operated by the Jet Propulsion Laboratory. We now report that this new processing of the lunar orbiter data has produced unexpected results. So we'll pick it up there on the next episode of Squaring the Circle. Thanks for joining me, John, and thanks for joining me, all of you folks that have been listening in. Please do check out the visuals that John will be posting, and feel free to make comments. And on that note, I have not much more to say, John. How about you?
Nope, all good.
All good. All right, my friend, thank you much. Until next time.
Yes, sir.